Hey everybody, welcome to Traits and Reproduction 2.1, Hemophilia, Proteins, and Genes. Um, let's jump to our warm-up right away because this is going to lead us nicely into where we are going in this lesson. So, warm up, Lord. There we go. Ooh, spiders. Sorry, I should have warned you. Those are some furry, thick ones. My gosh, look at that one. It's got like red on it. Ah, I do not want to walk into that spider web. Um, Here is our question. Why do organisms make different proteins? Now, hang on. Read that again. Why do organisms make different proteins? We talked about how organisms make different proteins for certain features, which gives them specific traits, right? For instance, the Darwin's bark spider on the left makes proteins that result in spider silk with high flexibility. The Darwin's bark spider on the right makes proteins that result in spider silk with low flexibility. Remember how we talked about that? It's all about how those proteins actually connect, which will determine, is that silk going to be flexible or is it going to be not as flexible? Using the space below, explain why you think this happens. So we know that it does happen, but okay, so why does a spider produce certain proteins as opposed to other proteins? We saw in that spider family tree, hey, all of those offspring, they all had different traits because they were making different proteins. Why does that happen? So go ahead and write your thoughts right there, and then come back to me. Cool. So we are moving forward. I look forward to hearing your thoughts of why you think spiders make different proteins. We're going to read now an article, Hemophilia, Proteins, and Genes. So let's first, before we jump into this article, let's review. We've learned that an organism's traits depend on the proteins in its cells. Traits from the flexibility of a spider's silk to the color of the spider to whether or not it's going to have bristles, whether or not it's going to be venomous. And, we extended our conversation beyond spiders, right? To our own traits. Our own traits are determined by proteins as well, whether your hair is straight or curly, what color your eyes are, how many fingers you have on each hand. Everything coming back to proteins in the cells. Where's our family tree? It's right here. We also learned that different organisms have different protein molecules, resulting in trait variation. Just like these offspring, they have different protein molecules. It looks like each one of them makes two protein molecules. Sometimes those protein molecules are the same. Sometimes they're different. We're going to learn some terms for how to sound really smart by saying, oh, they make the same protein, coming up in our article. So different organisms have different protein molecules resulting in trait variation. Next, we'll think about why that happens. Here is our chapter 2 question. Why do Darwin's bark spiders make different proteins for silk flexibility? That's where we're going to go by the end of our chapter. Today's investigation question is, how can organisms make different protein molecules for a particular feature? How do they actually make those different protein molecules? And how are we going to do that? Well, here we go. Dr. Satari, remember Dr. Satari from Bay Medical Company, sent us an article about a blood disorder called hemophilia, which is caused by differences in proteins. So what you're going to do is in Amplify, let me get there. There was the article. You can click right here in Activity 2 on that link. It's also just right there if you, I think, no, it's not right there if you scroll down. You can also go to the Amplify library up here to find that article. But when you do find it, it's going to look, hang on. It's going to look like this. You're going to read this article. And, ooh, look at that thing. What happened? Don't tell me it signed me out. Okay, I think it's back now. Look at that thing. It looks like a bunch of marbles all glued together. No, that's a protein. That's a protein. So what you're going to do is I want you to read through this article. And you might find that, wow, there's a lot of stuff in here. There's a lot of big words in here. Here is what I have for you. Attached to your lesson, I made this for you. It's a form for you to define 5 of the words that you find in the article. I've already chosen the 5 words. Mr. Wiggin, what would you like us to use for these definitions? Can we just look it up online? No, don't look it up online. If you click on the word, it will actually give you the definition. That's the one I want, okay? So read through the article, take a look at these diagrams. They are very informative. They will help you to understand more about what the article is actually talking about. And then define those terms for me on that form. I'll know who watched the video because everyone who didn't watch the video won't do it. So anyways, and then once you've read the article, once you've defined those terms, come on back to me. Hey, look, it's activity 3. Yeah, we're skipping that. You're welcome. Let's go to activity 4, the homework, exploring genes in the sim. I'm going to show you really quick about how to do this. It says launch the sim, then follow the directions below. Press on any spider, select a feature, notice the traits and proteins the spider has for that feature. Okay, let's go ahead and jump into the sim here. I'm going to pick Zora because Zora is my favorite. Okay, and then what did it tell me to do? It said select a feature. Okay, notice the traits and proteins the spider has for that feature. So I want to look at Zora's, how about size? Size, there we go. Now, here's what we're going to do. We get to play a little manipulation game here. 3 says, press on the black boxes in the upper right corner of the screen to change the gene versions. I just want to show you where to even find those, because otherwise you might miss it. They're these right here. So these are the gene versions, and what you can do is you can actually select, nope, I want it to make A2 instead of A1. I want this one to be A2. I want this one to be UC, and so on and so forth. Look for evidence that genes are instructions for the proteins. Guess what those black boxes are representing? Genes. Those are the genes that the spider has in the cells. And number 4, look for evidence that genes are instructions for proteins. Answer the questions below. What did you observe when you changed the gene versions? Do you think what you observed is evidence that genes are instructions for proteins? Why or why not? After you do that and answer those questions, you are done, and I will see you next time.